Friends, today we are going to discuss about the chapter chemical equilibrium, which is a vital chapter in the NEET syllabus. So let's start. I will discuss only the important points for NEET examination. Please note down this point. The state of equilibrium is not affected by the presence of catalyst. It only helps to attain the equilibrium state in less or more time. Please note down this point. Then if the reaction is small a capital A plus small b capital B, and the forward reaction rate is R1 and the backward rate reaction is RB, and the products are C capital C small d capital D, then at equilibrium rate of forward reaction will be equal to the rate of backward reaction. So at equilibrium in term of active mass, if we want to calculate the equilibrium constant in term of active mass, then the formula will be Kc equals to concentration of C whole to the power small c, which is the number of moles of C, number of moles of product C, then the concentration of C whole to the concentration of D whole to the power small d, concentration of A whole to the power small a, and concentration of capital B whole to the power small b. Then if we want to calculate the reaction rate constant in term of partial pressure, then the formula will be Kp equals to partial pressure of C whole to the power C, partial pressure of D whole to the power D, and partial pressure of A whole to the power A, and partial pressure of B whole to the power B. Then if we want to calculate the reaction constant in term of mole fraction, then the formula will be Kx equals to mole fraction of C whole to the power C, and mole fraction of D whole to the D, mole fraction of A whole to the A, and mole fraction of B whole to the B. Then note down this formula. Relation between Kp and Kc, we can write the relation between Kp and Kc. Kp equals to Kc into RT whole to the power del N. Del N in the change in number of moles when reaction goes from product to reactants. When note down these points. When del N equals to 0, then Kp equals to Kc. Obviously, when del N equals to 0, Kp equals to Kc. And when del N is greater than 0, then Kp is greater than Kc. And when del N is less than 0, then Kp is less than Kc. When determine, note down this point, while determining del N takes only gaseous species. Del N calculate during the calculation of del N, we have to calculate only the gaseous species. Then please show these graphs. These are the some important graphs related with the equilibrium. Please note down these graphs. Then the vital point. The unit of equilibrium constant is mole per liter whole to the power del N. Del N in the change in number of moles when reaction goes from product to reactants. The unit of equilibrium constant in the term of partial pressure is atmosphere whole to the power del N. Then next, if the reaction rate in the rate of reaction at T1 time T1 is K1, and the rate of reaction at time T2 is K2, then the formula then the relation between them is log of K2 by K1 equals to del H by 2.303 R into 1 by T1 minus 1 by T2. Del H is the change in enthalpy of the reaction. Then this is the reaction quotient. This is just when this is the reaction constant, this can be written as concentration of C whole to the power C, concentration of D whole to the D, and concentration of A whole to the A into concentration of B whole to the power B. If reaction quotient is equals to equilibrium constant Kq, then the system is in equilibrium. Please note down the point. And if the reaction quotient is greater than the equilibrium constant, then the system proceeds backward direction to attain equilibrium. Please note down this point. Then the degree of dissociation, the vital point. The degree of dissociation can be calculated by number of moles of reactant dissociated by number of moles of reactant present initially. Then the formula. Degree vapor density. Vapor density can be calculated. Vapor density equals to molecular weight by 2. Theoretical vapor density can be calculated as the molecular weight by 2. Then the important point, physical equilibrium. Physical equilibrium is nothing when a system is melting. Take an example of ice. When ice is melting for the heat, then this is an endothermic process and there is decrease in volume. Thus the favorable condition for melting of ice are high temperature and high pressure. As the volume is decreasing, though obviously there will be much high pressure, and in a water vapor system, then it is endothermic process, and so there is increase in volume. Thus in the favorable condition for vaporable water are high temperature and low pressure. This is the main content of the Lach-Atelier principle. In the Lach-Atelier principle, the scientist Lach-Atelier said that the reaction will be always try to goes to the favorable condition, so it will follow always in the favorable concentration. Please note down this box. If the concentration is increasing and del N is 0, then del N is 0 for forward direction. If the concentration is increasing and del N is 0, the reaction will go forward direction. If the concentration is decreasing and the del N is 0, the reaction will go backward direction. Thus if the pressure is increasing and del N is 0, then there will be no change in the direction of the reaction. If pressure is decreasing and del N is 0, then there will be no effect in the reaction. If the temperature is increasing in endothermic process, then and the del N is 0, then as the temperature is increasing in endothermic process, then the reaction will go for the forward direction. As the temperature is increasing in exothermic process, then the del N is 0, then the reaction will go for backward direction. If the rate of dissociation increase in pressure. If the rate of dissociation increase in the constant pressure and the del N is 0, then the direction of reaction will be unchanged. If the rate of dissociation increase in the constant volume and the del N is 0, then the direction of reaction will be also unchanged. Mixing of inert gas. If we add some inert gas at constant pressure and the del N is 0, then the direction of reaction will be unchanged. If we mix some inert gas at constant volume, then the and the del n is 0, then the direction of the axle will be unchanged. If the concentration is increasing and then del n is greater than 0, then the direction will be goes for forward direction. Please take a screenshot of this column. This is very important column about the Lach-Athaliah principle. If the concentration is increasing and the del n is greater than 0, then the reaction will be goes for forward direction, and the del n is less than 0, then the reaction will be also goes for forward direction. Thus this is very important. This is a very important chart. Please take a screenshot of this chart. Also I am giving this document in my description. You can check it out from my description. So this is for today, and if you like this video, please subscribe the channel and press the bell icon.